So welcome everybody. Good afternoon. Thank you for joining us. So today we're going to be giving a presentation on observability and using OpenTelemetry with IRIS. So I'm Devon Haigh. I'm a product manager with InterSystems. And I'm going to be starting off the presentation, and I'm going to be passing over to my colleague here, Jasper. He's going to be giving a demo of some of the new features that we were adding and will be available in 2025.2. So with that, we'll get going. So our agenda here is I'm going to give a little bit of an introduction to OpenTelemetry. I'm kind of assuming that a lot of people here probably have some degree of familiarity, but I'm also assuming that maybe a lot of people are new to this, et cetera. So I'm going to give a little introduction to OpenTelemetry, what it is, how it came to be, what problems it solves for you in your data center, and why you might want to be using it, et cetera. We're going to talk a little bit about what's available right now in IRIS 2025.1. And then we're going to give a preview as to what's coming in the next release, 2025.2, some of the new features that have been added around tracing, et cetera, which Jasper's going to be presenting. And then some how it gets used in practice, et cetera. And hopefully this gives everybody a really nice overview of what's available today, what's coming, et cetera. So OpenTelemetry, just quick show of hands. How many people here are familiar with OpenTelemetry, have used OpenTelemetry? Okay. How many people have no idea what OpenTelemetry is? Okay, a couple. All right. So we're going to talk a little bit about observability and what it is that OpenTelemetry is doing in that observability space. So what is observability and why do we need it? Okay. So a long time ago, our systems were much less complicated. Harkening back to the days of mainframes and single server websites and et cetera, where everything was all in one box. Observability, and by that I mean knowing what's going on in your system. Right? Being able to see log messages, being able to understand how system resources are being used, et cetera, was pretty straightforward. If you had a single monolithic sort of architecture, you go to that one single monolith and you can go and look at your CPU, your memory, you can look at log events, et cetera. But as time went on, very quickly our data centers and our systems got more and more complicated. And we moved into the internet age, we moved into multi-tier architectures, we moved into cloud services and microservices, where a lot of your computing is very distributed across many different hosts, different processes, maybe even different data centers and regions of the world. And this really complicated the process of being able to understand what your systems are doing, how they're performing. It complicated the process of being able to diagnose problems, et cetera. And so what are we really talking about when we talk about observability? Okay. So typically these days we talk about observability in three main categories. Log events. Now, log events are sort of like the oldest and most traditional form of observability. Your application, your system, et cetera, when things happen, it writes out log messages. And in the very beginning days of this was a text file or whatnot that you could go and tail and look at, et cetera. But logs, it's intended to record an event happening, and so that you can retroactively go and look and understand what was happening at any one time. The second category here is metrics. And metrics we typically talk about things that are time series data. And the most common form of this is when people are collecting performance metrics from their systems. They're looking at things like CPU utilization or memory utilization. And it's a series of data points that are a data point associated with a timestamp. And it's obviously very useful for understanding trends and things and patterns over time. And last here we have traces. And traces are one of the most recent additions to sort of the observability space. And traces are a little bit different. Traces, rather than trying to allow you to track or have observability into one specific thing that was going on in one particular host or with one particular process, traces intends to really give you a visibility into an interaction with your system, something from beginning to end. And that might traverse across many, many different processes, especially if you're talking about a microservices architecture. So if you had, say, you're trying to track what happens to a particular web request. There's a lot of different things that go on with servicing a single web request, right? There's a web server component, there's looking up data on the back end, there's an app server, et cetera. And so there's a lot of different places that something could go wrong. So traces are a format here of observability where we can follow that one interaction with the system along and see data from potentially different hosts, et cetera. And so for inside IRIS, we have solutions for all of these things. And for a very long time, we've had our structured log format, which allows people to have the system log and the audit DB and customize what goes into those logs, et cetera. We've also had our metrics API, which allows you to get on a lot of those time series datas on your IRIS host, et cetera. Traces are something that we also have a solution for. Starting in 2024.2, we added some trace functionality here with our OpenTelemetry stuff, and we'll talk about all of these things a little bit. So what's OpenTelemetry and how does it fit into this? Well, so for a long time, there have been commercial solutions in the telemetry space, in the observability space, but they were often proprietary solutions. They required you to, engage with the vendor, go and purchase it, and then typically it was, I go and install the agent on my hosts, and it collects data, and it sends it back to a centralized location. So more recently here, and this was really once we started getting into sort of the cloud revolution that we're experiencing these days, along came OpenTelemetry. And OpenTelemetry was actually a couple different open source projects that merged. There was OpenLogs and OpenMetrics. They decided to team up. And this was really because they wanted to take a different approach to telemetry in general. They decided that rather than taking the approach of a proprietary space, I develop an agent and give it to you so you can put it on all your hosts, they decided to take the approach of an open standard that could be interoperable with a lot of different things. So OpenTelemetry is one of the incubator projects of the Cloud Native Computing Foundation, which in turn is a part of the Linux Foundation. And it is one of the very successful things that have come out of their incubation process. They sort of came to market with more of an open approach of let's allow all of these things to talk together with a common format and a common way that we can collect all this data and provide observability. And that really kind of changed the landscape of observability and telemetry in general. Suddenly, we went from commercial proprietary solutions for this space to an open ecosystem that could really collaborate with each other. And because of this, they've really kind of taken this space by storm a little bit. Nowadays, when people talk about telemetry and metrics and et cetera, almost invariably OpenTelemetry is part of that conversation. So let's talk a little bit about how OpenTelemetry works and how it works with IRIS here. So there's probably, if you're familiar with observability and metrics and AP, there's probably a bunch of logos up there that you're familiar with. So these are all of those proprietary solutions. I mean, some of them are open source, but they all sort of had that model of, an agent you install, it collects data, it sends it to the centralized location. OTel is a little bit different, OTel being shorthand for OpenTelemetry, where they have a common interface for how it collects the data, and a common way for a lot of these different telemetry solutions to receive data from OpenTel. And that means that you can use usually the tool of your choice for viewing and analysis and data storage and et cetera. But you're now not constrained by having to have agents that run on every single host and that sort of burden. So what we've done here in IRIS is we've taken the OpenTelemetry SDK and implemented it directly in the IRIS kernel. And this means that we have the ability to collect a whole range of information out of IRIS itself. And then we've implemented an OpenTelemetry exporter directly inside of IRIS. So there's no additional software that needs to be installed, et cetera. It's really just a matter of turning it on at this point. And it will now be exporting all of its OpenTelemetry data to an endpoint that you specify. So in this case, you would set up an OpenTelemetry collector. Now, an OpenTelemetry collector is the software piece that the OpenTelemetry project provides. And it solves a bunch of problems in terms of scalability of your telemetry system. It's designed to be able to take lots and lots of inputs from lots and lots of different hosts simultaneously and deal with that bandwidth. Has internal processors that allow you to, batch and transform and et cetera that data, and then exporters that will allow you to take all of that data and push it into any of your telemetry backend infrastructure that you want. A lot of those exporters it's really a plug-in interface. A lot of those exporters are, a collaboration between one of these things in the telemetry backend box there and OTel itself. Most of the time, if you have any type of telemetry infrastructure, you can very easily go and find the OTel plugin, get it talking to your collector, et cetera. And one of the real powers of OpenTelemetry here is that it's not just IRIS that it can collect data from. As I said, OpenTelemetry has really been taking the space by storm, and a huge number of things out there now have the ability to emit OpenTelemetry signals in that OTel format, which you can again point directly at your collector. And this means that you can pull data and telemetry from the operating system. If you're using Kubernetes and that type of a situation, you can pull directly from your Kubernetes cluster, your network appliances, your load balancers. Almost all of these things will likely be able to emit these metrics and whatnot in a very useful way for you suddenly. So what's exactly in IRIS 2025.1 right now today? So first and foremost, ease of setup. Okay, it's really a two-step process. You set an environmental variable that really defines where your OTel collector endpoint is. And then you turn it on. There's a couple flags that you can use. You can get on this through the management portal. There's a picture of the UI there. But you can also do this through configuration merge and things like that very easily. So that's all there is on the IRIS side to set it up. You turn it on, you define an endpoint, you say emit logs, emit metrics. So obviously you can change those values if you want, and there's some configuration there. But what does that get you when you do that? Okay, so as soon as you do this, it means that your IRIS instance will be taking everything that goes to system log and gets emitted via the OTel logs API. Everything in your audit DB can get collected by OTel now. Everything that you have configured through the metrics API to be collecting, you can be admitting here as an OTel signal. And this allows you to really get on a lot of data. But now there's also trace availability here. And now traces, as I said, are kind of the new kid on the block in the observability space. And with 2025.1, there's also a trace API that's been added, which allows you to instrument your applications, et cetera, with traces, and then have traces emitted to OTel as well. Jasper is going to be talking about some of the brand new features that we're going to be seeing in 2025.2 around some built-in traces, but I'm not going to steal his thunder. I maybe talked over this slide a little bit here already, but as I said, you get a lot of this stuff out of the box. You turn it on, you set your endpoint, and boom, you're off to the races. And last but not least, it's customizable. And it's customizable in very familiar ways for you. Anything you can do with the system log, anything you can do with the audit DB, you get it for free as soon as you turn it on. Traces are really something that you would be instrumenting your own application with, et cetera. We are going to be talking about some built-in stuff that we're adding. So down here below are some pictures of some user interfaces of some two very, very popular tools to use in the observability space. This is Jaeger and Prometheus. And so Prometheus is, again, an open source tool. It kind of came out of the cloud space, but Prometheus can be used for observability with anything. It natively communicates with your OTel collector, et cetera. And it's great for looking at time series data, metrics, CPU stuff, et cetera, that type of monitoring. Jaeger here is this kind of a picture of what a trace might look like, where you can see what's happening across different processes, different hosts, and you can see where long poles are and things like that. And with that, I'm going to hand it over to Jasper, who's going to be talking about what's coming next in 2025.2.
Thank you, Devon. So next, I will talk about what's coming to our next version, 2025.2. There are three things. We will have trace for web applications. We will have trace sampling. We will also have performance improvements and bug fixes. So let's first talk about span. We know that OpenTelemetry generate traces. So traces are composed of many spans. So a span is a unit of work or operation. And you can see in this diagram that every operation is a span. And a span can also have sub-operations called child spans. So you can see we have a root span here. That's a dashboard request, and the request can call 3 other services or APIs. So, and these APIs can also have sub-operations. So from a span, we can know when an operation starts and ends. Also, the span can come from different services. So they are in different colors. This can be in a distributed system, but all the operations are in one diagram. So next, I will talk about the first feature, traces for web applications. Why we have this is because for traces, you have to manually write code to emit the traces, but manually adding traces to every web application is a tedious process. So we provide you a default setup that you can just enable. So how does it work? When a HTTP request comes in, we will start a span for you. And after you done processing the request, we will stop the span. And we also support the W3C trace context, so you can provide your own trace parent and state. And In our trace propagation classes, we provide some methods to help you inject and extract this trace context. So how to enable the web application tracing? You can do it from two places. You can do it from the management portal, it's very easy, or you can do it from the terminal. So after enabling the web tracing, you will see the traces when you make a request to the web application, and there will be more examples for the traces later. And the next feature I will talk about is trace sampling. So why we need sampling? Because we might not need all the data from the traces. We might only need traces with specific attributes. For example, if it has errors or it is high latency, and we only need a small sample of those OK traces to offer the insight. And for high volume systems, a sampling rate of 1% or lower may very accurately represent the other 99% of the data. So eventually, this can reduce the cost of observability and without losing visibility. So to sample a span, you will need a sampler. So how this works? When a span comes in, it will make decisions. It will either drop it or sample it. There is also a special operation called record only, which means you can use it to do some calculation and the span will generate it, but it will not be emitted. We provide some pre-built samplers for you. The first one is trace ID ratio-based sampler. It's an easy sampler. It's just sample you can specify a percentage of spans to be sampled. And the next sampler is parent-based sampler. This is a little bit different because you can set different sampling rate based on if the parent is remote or sampled. For example, I can say if the parent is sampled, we decided to also sample its child. If the parent is not, then we drop the child. And we can also do similar things to the remote spans. There are also other two samplers, always off sampler and always on sampler, which you can use to turn on or turn off trace. And you can also create your own sampler classes by implementing the abstract class. So let's see how we do trace sampling in code. It's an easy process. You only need one line of code. You need initiate a sampler object. So in this example, we use a trace ID ratio-based sampler with a 10% sampling rate. And you notice that we hard-coded this rate in our code. However, the best practice is to make this rate configurable in your code. So in this example, we emitted 20 spans, and only 2 spans are sampled. So next, I will use a real example that we simulated to show you how do we use OpenTelemetry to debug. So this is a simulated issue only for demonstration purposes. So I will talk about the problem. The problem is there is an API called dashboard, and we find the request is slow. And what the dashboard API does is it will call 3 other APIs. It will call the appointments, lab results, and patient profile, and get all these data to show a dashboard. And the problem is the response is slow. However, it's hard to identify where the problem happened, so we will need OpenTelemetry. I will first talk about the tools that we use. We chose two open source tools, and there are also other tools like Datadog that you can use, but we use two open source tools for this demo. The first tool is Jaeger. Jaeger is an open source tool to visualize those request flows, so it's similar to the diagram in the previous slides. We also use Prometheus. It's an open source system for collecting and querying and alerting on the metrics, and we use it to show some span metrics. Let's see how this setup works. So first, IRIS will emit all the traces to the OpenTelemetry collector, and the collector will emit the spans to Jaeger. So in Jaeger, you can see all the spans. The collector will also collect the span metrics, such as the latency and the request rate, and save them to Prometheus. In this case, Jaeger can query the metrics from the Prometheus to show the traces and the metrics at the same time. In the next page, we will see a span matrix. So this metric is for the dashboard service. In this service, we have a root span called getDashboard. And we can see the latency of it are going up as we make more and more requests. But we still don't know what happened, so we will need to see the metrics for other two services. This is the IRIS web service, and in this service, we have two spans that looks good. The latencies are not high, so we can know that the problem are not in these two operations. In the last service, we can see 3 spans, and 2 of them have increasing latency. So probably the problem is located in these 2 operations. And we will see the relationships of these spans in the trace details. And also from this page, you can view all the traces. So every request will generate a trace, and there is also the latency. And we will see the first trace to see what happens. Now we have the first trace. And so in the red box, you can easily see that one operation is taking a very long time. And I will explain a little bit about this image. So it's a very similar diagram to as the previous slides. We have a root span, and root spans have some different steps. So one of the steps is very slow. So in this case, we don't need to go into every instance to see the logs. We can just see it in this one page. And so the simulated issue is very easy. We just want to simulate that the service will download all the generated PDFs from the remote service when you are only providing a new one. If you are interested, here are the source code of it. So in conclusion, we know that OpenTelemetry is a standard way to collect traces, metrics, and logs across multiple services and enable proactive monitoring and faster debugging. Also, the new features, sampling and web tracing will reduce the overhead and improve the trace quality. So you are welcome to sign up for the early access programs. If you are interested, you can scan the QR code. Also, don't forget to take the session survey. You can find it under your profile. And that's all for today's presentation. And if you have any questions, you can ask us. Thank you. Right?
What kind of performance overhead? Obviously, with all the performance overhead.
Yeah. So OpenTelemetry is very efficient. It's written in C, and so it's for like large amount of the traces, designed for large amount. So it will not be a lot of overhead. You will not see it. You're not supposed to see much difference.
You could use OpenTelemetry to figure out exactly what the impact is.
So actually, as a piggyback off of his question, do you have something native to IRIS? Do you have something native to IRIS 2025.2 where it will measure the impact of the tracing or any of the telemetry that it's gathering?
Where is the question coming from? Okay. Sorry, could you repeat it? Could you repeat the question?
So when you enable this tracing on IRIS, does it actually also send how much of an impact it's having on the system when it's performing the pulls? As a piggyback off of his question. So when you're actually pulling this information from IRIS and it's sending it out to whatever receiver, does it actually include within it how much of an impact it has on IRIS to gather these traces or any sort of telemetry?
I think the trace itself will include this time.
It will? Okay.
I have a web application that is acting as an endpoint for multiple different class methods. Could be 50 or 100. You tie the sampler to the web application, so what is the granularity of measuring each of them? And part two of the question, does the new classes of the sampler are available to inherit to any persistent class, for example, to be able to measure different operation on that class, like percentage new, OpenID, or whatever?
So I think for the sampler class, you are supposed to adjust the rate yourself. This is a manual process, and you can inject this sampler to any place you want.
Thank you.
Well, if there's no more questions, thank you very much, everybody.